Hello, this is Ms. DB. In this video we are going to work more with some quadratic functions and with graphing them. So especially we're going to be looking for the x-intercepts, which are also called the zeros or the roots, and we're going to be looking for the axis of symmetry from these graphs. So an x-intercept is when y equals 0. So we can see on this graph here, it's a little bit small, but we can see there's two places where this parabola crosses the x-axis, or when y equals 0. So we call these many things. We call them the x-intercepts, just like we did with linear functions. We also call them the roots, and we also call them the zeros, and we even also call them the solutions. So they have like 4 different names. So don't get concerned if it's called one thing or the other. In this example, they're saying find the zeros. The zeros mean the roots or the x-intercepts. And we can estimate what these are from the graph. And especially if they cross at nice integer points, we can be pretty sure that those are the roots. Later, next week, we will also find those exact values by factoring, by looking at something called the quadratic formula, and by solving the equation using square roots. So there's different ways to solve algebraically, but today we're just going to look at those but from the graph. So in number 1 and 2, you're just going to estimate the zeros from the graphs. Remember, these are just the x-intercepts. Note that sometimes there is no real roots or no real zeros. It never crosses the x-intercept sometimes, if it's been moved up or if it's an opening downward parabola that has been moved down. And that can happen. There are actually some imaginary roots, if you remember when we looked a little bit earlier in the year at what an imaginary number is, and we will find those imaginary roots when we are in Algebra 2. But for this class, we're just going to be looking for the real roots. In 3, 4, and 5, same thing. First, name how many zeros there are. Is there 1 0, 2 zeros, or no zeros? If there's no zeros, you can't name it. And if there is 1 or 2 zeros, then name them. When you write your answers for these, you can just give the x value of the coordinate, or you can write it as a coordinate point. Like in number 1, you can write the zeros for this as, let me get my pen here. You could say it's at -4, 0, and the other root would be at, looks like 0, 0. Or you can write that the roots are at -4 and 0. But you cannot put them together in one parentheses and expect that to mean 2 different roots. So for example, let me go back to one that it didn't have 0. Like in letter A, example 1A here, you could not write those roots as -1, 2 in parentheses like that, because that means something different. That means the point x is -1, y is 2. X is -1, y is 2. That would be that point. So you can write them just like this with the and in between them, or you can write them both as coordinate points if you prefer, but they would be 2 separate coordinate points. Make sure you note that. And then we're going to look at axis of symmetry. What the axis of symmetry is the point at which you could fold this parabola so that it would look exactly the same on the left side as on the right side of the axis of symmetry. The axis of symmetry is a line. And lines are equations, you can write equations of lines, and this line is going to be at x equals something. You cannot say that the axis of symmetry is 1. You have to say that the axis of symmetry is x equals 1, because that gives us the equation of that vertical line. So if you just write that the axis of symmetry is at 1, that would be wrong. The x-coordinate of the vertex is 1, and let's see, the y-coordinate would be -4. So the x-coordinate does match up to your axis of symmetry, but you have to write x equals before you'll get the correct axis of symmetry. So there's a couple examples there. There's another way to find the axis of symmetry than by looking at it from the graph. Well, you're still looking at it from the graph, but you're looking at the x-intercepts or the zeros. If you write down, or if you've already found the x-intercepts, for example, in this one, the x-intercepts are at -3 and 5. Those are the two x-intercepts. You can add those together and divide by 2. What you're doing is finding the average of them, which will be the number in between those two, and that would be 2 over 2 equals 1. So the x value of the vertex is 1, and the axis of symmetry would be x equals 1. So there's more than one way to find the axis of symmetry. There's even another way using the equation of the parabola. If you're given a quadratic equation, you can find the axis of symmetry as well. So let's look at this. So in a quadratic equation, in standard form, it's written y equals ax squared plus bx plus c. And remember that if, in example 3, you can see if there's no number written in front of the x squared, a is 1. You could put a 1 there if you wanted. You don't have to, but you could. So in this one, a is 1, b is 3, because that's the number in front of the x, and c is 4. And we're going to use the equation x equals negative b over 2 times a in order to find the equation of the axis of symmetry, even if we don't have a graph. So you could graph and check it, but this is also a good way to find it if your axis of symmetry is not at an integer value, if it's a decimal or a fractional value. So to do this, all we do is we use the formula. We plug in b here, so that would be 3, and 2 times a, that a is 1, so 2 times 1 is 2, so negative 3 over 2, which we could leave it like that if we wanted, or negative 1.5. And then when we write the equation, remember it has to be x equals, and then the value that you found. So in this case, it would be x equals negative 1.5. What if, I want to see one if we have a negative. Let's look at number 10, because sometimes the negative is confusing for people. So the equation is, for the axis of symmetry, x equals negative b over 2a, or the negative can be in front. These are the same equation, doesn't matter which way you write them. So if I'm going to, let's first identify a, b, and c. A would be, first of all, make sure this is in standard form. Something x squared plus something x plus a number, constant. Okay, that's good. So this is negative 3, this is a positive 18, this is a positive 1. We're not going to use the c, but it's nice practice to identify what that is as well. So our equation, let's use this form here where it's negative b on top, would be negative b. B is 18. Oh, I was thinking this would be a negative. That's okay. And this would be over 2 times a. A is negative 3. So I have to simplify this. Let's simplify. On the top, I'd have negative 18. On the bottom, I would have negative 6. A negative divided by a negative is positive. So I get 3, but remember, you have to write x equals 3, not just 3. Covered up the x there. All right, 11 has b for a negative. Let's fill in a, b, and c on 11. A would be 2, b would be negative 3, c would be negative 4. So when we do this equation, x equals negative b over 2a, I'm going to fill in negative b. But b is negative 3. So you have negative, negative there. And on the bottom, we have a positive. So a negative times a negative is a positive. So if you have 2 negatives in a row, that'll be a positive, and then that'll be 4. So you'll still have to fill in. It's okay to have you can change that to a decimal if you want. You can just go 3 divided by 4th, or you can leave it as 3/4. And in the last question here, I think this is the last one. Yep, you're going to do lots of the things that we've talked about in the last few worksheets in this week. So you're going to talk about how it opens, whether it opens up or down, you'll find the vertex, and so on. You can also, because the equation is given to you, you can graph this at Desmos if you'd rather be able to like zoom in and click on points and find the exact values. When it asks you for the zeros, remember those are the x-intercepts, or the roots. And when it asks you for the axis of symmetry, don't forget to write x equals. All right, let me know if you have any questions, and have a wonderful day.